Good evening, students. Okay, all of you, please switch on your videos. All of you, please switch on your videos. Abhinav, Anashwara, Gaya. Okay, Gaya. Those who are not facing any kind of network issues, all of you, please switch on your videos. Okay, children. So, in our last class, we discussed about the vector addition using parallelogram law and triangle law. Okay, so starting with John Joss.
Yes, ma'am.
Can you state the triangle law of vector addition?
If we have two vectors, then if we arrange it as the two sides of a triangle,
Okay.
then the sum of the two vectors will be the third side.
Okay, then the resultant vector is represent the third side of the triangle. But what about the order? Is it in the same order or in opposite order?
No, ma'am. The resultant order will be in different order.
Okay, the resultant vector should be in opposite order. All right, good dear. The next one, Malaviga Vibin. Tell me the parallelogram law of vector addition. Same question to Anaga. Parallelogram law of vector addition.
Ma'am, if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a same point,
Yes.
and their resultant is represented in magnitude direction by the diagonal of the parallelogram.
Okay, then the resultant is the diagonal of the parallelogram that is also starting from the same point. So that's all about the vector addition using graphical method. So under the graphical method, we discuss mainly three different cases. The first case, if the two vectors having the same direction. The second case, if the two vectors are to be added with the opposite direction. And in the third case, if the vectors are inclined at an angle theta. In that case, we have two methods are there. One is triangle law and other is parallelogram law. If the two vectors are arranged in same order, then we can use the triangle law of vector addition. And if the two vectors are arranged or they are starting from the same point, or in other words, we can say that if they are co-initial vectors, then we can use the parallelogram law of vector addition in order to find out the resultant vector. So that's all about the vector addition using graphical method. Now we are moving to the second method of vector addition. So can you recall what about the second method of vector addition? What is our second method of vector addition? We have three different methods are there. One is graphical method. The second one is analytical method. Analytical method. So all of you write the next heading. Vector addition using or vector addition by analytical method. Vector addition by analytical method. Okay, write the first statement. Consider two vectors. Consider two vectors. Vector P and vector Q. Consider two vectors. Vector P and vector Q. With magnitude. Consider two vectors, vector P and vector Q with the magnitude P and Q respectively, with the magnitude P and Q respectively. Such that inclined at an angle theta. Such that it inclined at an angle theta. So this is the condition that we are consider in order to describe the vector addition using analytical method. So here we are consider the two vectors, vector P and vector Q. They have the magnitude P and Q respectively. And these two vectors are inclined at an angle theta. That is, these two vectors are joined and they make an angle theta. Okay, so let us draw the figure. First of all, we can arrange these two vectors. So here we have vector P and this is vector Q.
Ma'am, can
Vector.
you show the definition again?
Okay, consider two vectors. Consider two vectors, vector P and vector Q, with magnitude P and Q respectively, such that inclined at an angle theta. Such that it inclined at an angle theta. Consider two vectors, vector P and vector Q with magnitude P and Q respectively, such that it inclined at an angle theta. So here we are going to find the resultant vector of this case. So we arrange the vectors P and Q like this. They are joined from a point and thereby they making an angle theta. Okay. Then students, by observing this figure, can you say how we can solve or how we can find out the resultant vector here? Which law can be applied here in order to solve the resultant vector or in order to calculate the resultant vector?
Parallelogram.
Very good, excellent. Here we can use the parallelogram law because here the two vectors, vector P and vector Q, having the same end point or same initial point. Both of them have the same starting point. So as we studied earlier or as we told earlier, if the two vectors, they having the same magnitude or they are starting from same initial point, then the resultant vector should be the diagonal of the parallelogram law. Okay. So here we consider the two vectors P and Q. They are co-initial vectors starting from the same point and they are making an angle theta. It is inclined at an angle theta. So after drawing this figure, you can write the next statement. Here, the resultant vector can be determined by, here the resultant vector can be determined by applying the parallelogram law. So by applying the parallelogram law, we are going to describe the vector addition by analytical method. Okay, so in order to explain the method of vector addition by analytical method, here we are combining the parallelogram method. Okay, so here the resultant vector can be determined by applying the parallelogram law. For that, we consider a parallelogram, that is draw a line parallel to vector P, draw a line parallel to vector P, and draw another line that is parallel to vector Q. Draw a line that is parallel to vector P and draw another line that is parallel to vector Q. So here we want to calculate the resultant vector formed by these two vectors, vector P and vector Q, using analytical method. For that, we are going to apply the parallelogram law because here the vector P and vector Q are starting from the same point, same initial point. So here we are going to apply the parallelogram law. In order to apply the parallelogram law, here we consider a parallelogram. For that, we draw a line parallel to vector P and draw another line that is parallel to vector Q and name the parallelogram as O, A, B, C. So it becomes a parallelogram with the name OABC. Then by parallelogram law, here the resultant vector is the diagonal of the parallelogram. Then by parallelogram law, here the resultant vector is the diagonal of parallelogram. That is vector R is equal to vector P plus vector Q. Then by parallelogram law, here the resultant vector is the diagonal of the parallelogram, that also starting from the same point. That is vector R is equal to vector P plus vector Q. Okay. So up to here, this is the application of parallelogram law of vector addition. Now we are going to enter into the analytical method. So here we get the resultant vector. According to parallelogram law, the resultant vector is the diagonal of this parallelogram, that is starting from the same point as that of the vector P and vector Q. Now we want to calculate an expression for resultant vector. Now we want to calculate. After drawing this resultant vector, all of you write the next sentence. Now we want to calculate the magnitude and direction of this resultant vector, vector R. Now we want to calculate the magnitude, because the resultant vector is vector R. It's a vector quantity. It must possess a magnitude and a direction. So here we want to calculate the magnitude and direction of this resultant vector, vector R. Now we want to calculate the magnitude and direction of this resultant vector, vector R. Okay, so from here onwards, the analytical method starts. In order to find out the direction and magnitude of the resultant vector R, here we are going to elongate or extend. So in order to find out the magnitude of vector R, that is the resultant vector R, extend the region OA. Extend the region OA. To find the magnitude of vector R, extend the region OA and draw another line that is perpendicular to this extension. In order to calculate the magnitude of resultant vector, vector R, here we extend OA, then draw another line from B perpendicular to this extension and mark this point as D. Okay. The half part of, or the initial part of the analytical method is exactly the same that we are doing in the parallelogram law of vector addition. Okay, using the parallelogram law of vector addition, we find that here the resultant vector is the diagonal of the parallelogram, that also starting from the same point. But in order to find out the magnitude and direction of that resultant vector, here we need to apply the analytical method. So in order to apply this analytical method, here we extend the region of OA. The region OA is extended. And we draw another line from the point B that is perpendicular to the extension. It is joined at a point and we take that point as D. Okay, so now we can observe this triangle ABD. It is in the form of a right angled triangle, right? Or you just observe the triangle OBD. Observe the triangle OBD. Now consider the triangle OBD. Consider the triangle OBD. It's a right-angled triangle. The triangle OBD is a, or ODB, I think it is better. Instead of taking ODB, ODB. Consider the triangle ODB. It is a right-angled triangle. So what is angle D? ODB is a right-angled triangle. So what is angle D represents?
90 degree.
90 degree. Okay. So here, consider the triangle ODB such that angle D is equal to 90 degree. We need to find out some findings from this figure. So angle D represents 90 degree. And here OC, the vector Q. OC is equal to vector Q. Then what about the region AB represents AB? If OC is vector Q, what about the region AB?
Vector Q.
It is also represents vector Q because they are parallel sides. So OC is vector Q. So we can say that AB is also equivalent to vector Q with the magnitude Q itself. Okay. So here we have two vectors P and Q. By applying the parallelogram law, we find the resultant vector. Here the resultant vector is represents the diagonal of the parallelogram. Then in order to find out the magnitude and the direction of this resultant vector, here we are going to use the analytical method. For that, here we extend the region OA and draw another line from the point B. It is joined at a point. We mark that point as D. So we get a right angle triangle ODB with the D is equal to 90 degree. And here the portion or the region OC is represent vector Q. If OC represent vector Q, we can say that AB is also represents vector Q. And similarly here, the vectors Q and vector P. The vector Q and vector P makes an angle theta. So if the angle between vector Q and vector P is theta, what about the angle between this vector Q and AD? What about this angle? This is the basic mathematics. If the angle between this OC and OA is equal to theta, what about the angle between BA and AD? No idea.
Theta.
That is also equal to theta. So here the angle between the two vectors, that is vector Q, angle between vector Q and vector P is equal to theta. Therefore, angle between BA and AD is also theta. Angle between BA and AD is also equal to theta. That is, this angle is also equal to theta. Okay, so here we are going to find some findings from this figure and mark all the values corresponding to OC, AB, and what about the angle made by the vectors and that of the other side of the triangle and all. Now again, consider the triangle ODB. From the triangle ODB, we can apply the Pythagoras theorem. By applying the Pythagoras theorem, What is the Pythagoras theorem states? Applying the Pythagoras theorem to this right angle triangle ODB. By applying the Pythagoras theorem, we have according to Pythagoras theorem, we have hypotenuse square is equal to, any idea?
Base square plus altitude.
Hypotenuse square is equal to base square plus altitude square. So we want an expression for the magnitude of resultant vector. That is why we are using all these methods here by considering the right angle triangle, and thereby we are applying the Pythagoras theorem. According to Pythagoras theorem, we know that hypotenuse square is equal to base square plus altitude square or height square. Okay. So by applying the Pythagoras theorem, we have hypotenuse square is equal to base square plus altitude square. So from this triangle ODB, what is our hypotenuse?
OB.
Yeah. So this is our right angle triangle OBD or ODB. So from this right angle triangle, we know that OB is the hypotenuse. So mark it here. That is OB square equal to, what about the base? Base square
OD.
OD square. OD square plus, what about the altitude square? Height
BD square.
BD square. All right. And what is OB? Or we can simplify this equation. OB square is equal to, what is OD? OD. Split this OD into two. The line OD is equal to, here we have two parts, OA and AD, right? So OD is equal to, or OD square is equal to OA plus AD the whole square. We can split the entire line OD. Here in between O and D, here we have A. So we can split this line OD is equal to OA plus AD. Is it clear? So we just split this term into two. OB square is equal to OA plus AD the whole square plus BD square. So by applying the Pythagoras theorem, we have hypotenuse square is equal to base square plus altitude square. And here from the figure, the hypotenuse is represented by the region OB, base is represented by OD, and altitude or height by BD. So hypotenuse square is equal to, that is OB square is equal to base square OD square plus altitude square, that is BD square. But here again the base is split into two region, that is OA plus AD. Now we can substitute all the values. So here we have OB square is equal to OA square, OA plus AD the whole square plus BD square. What is OB? From the figure, what is OB? What is OB represent? This is the diagonal of the parallelogram. So what is OB? Yeah, it's right. What is the resultant vector? It is represented by vector R, right? So here OB square is the resultant vector of this parallelogram. We know that the resultant is the diagonal of the parallelogram that is starting from the same point. So it is represented by vector R. Okay. So here we have OB is the vector R. But we take the magnitude here. So it is R square. Vector P, magnitude of vector P is P. Similarly, vector Q, magnitude of vector Q is Q. Similarly, resultant vector, magnitude of the resultant vector is R. So instead of writing vector R, here we can take the simply the R. R square is equal to, what is OA? OA.
Vector P.
Vector P. And what is the magnitude of vector P? P. P. So here instead of OA, we can write P plus, any idea about AD? What about AD? No idea. Here we don't have any value for AD, so we can put the AD as it is. P plus AD, the whole square, plus what about BD? Is there any particular value for BD? No, nothing. So we can put the BD as it is. So here we want to find the value for AD square and BD square, or AD and BD. So our equation become R square is equal to P plus AD the whole square plus BD square. And here we want to find the value for AD and BD. So in order to find the value for AD and BD, consider the triangle. In order to find the value for AD and BD, consider the triangle. Consider the triangle ABD. Consider the triangle ABD. So here we are consider this triangle in order to find the value for this AD and BD. Okay. So consider the triangle ABD. The small triangle. I will mark it with another color. Consider the triangle ABD. This one. So here we consider the triangle ABD. From this triangle, what is cos theta represents? Cos theta. In trigonometry, what is cos theta? Cos theta is equal to adjacent side divided by, complete it,
Hypotenuse.
hypotenuse. Cos theta is equal to adjacent side divided by hypotenuse. So in order to find the expression or value for the portion or the region AD and BD, here we consider the triangle ABD. From the triangle ABD, here we consider this angle theta. Angle theta, that is cos theta. Cos theta is equal to adjacent side divided by hypotenuse. What is the adjacent side here? Cos theta. AD. AD is the adjacent side. So here we have cos theta is equal to, once again I write the equation, cos theta is equal to adjacent side divided by hypotenuse. Or cos theta is equal to adjacent side is AD. From the figure it is clear that adjacent side is AD. And what about the hypotenuse? Hypotenuse of this triangle ABD. AB. AB. All right. AB is the hypotenuse. Okay. Or we can write cos theta is equal to, we don't know the value of AD, so write the AD as it is, divided by, what is AB? What is the value of AB from the figure? AB.
Vector Q.
Q, vector Q with the magnitude is equal to Q. So here AB is equal to Q. So here AB is Q. So we get cos theta is equal to AD by Q, which implies AD is equal to, what is the value of AD then? AD is equal to
cos theta into Q.
cos theta into Q, or we can write Q cos theta. Bring this Q to the LHS, so it becomes multiplication. AD is equal to Q cos theta. Okay, so we get the value for AD. We also want to calculate what you mean by BD. So the AD is over. Now we can calculate BD from the same triangle ABD. So again from the triangle ABD, from triangle ABD, sin theta is equal to, what is sin theta? Cos theta is adjacent side divided by hypotenuse. Then what is sin theta?
Opposite side by hypotenuse.
Yes, exactly. Sin theta is equal to opposite side divided by hypotenuse. Or we can write sin theta is equal to, again from figure, what about our opposite side? If it is the sin theta, opposite side by hypotenuse. What is the opposite side here? Opposite side of sin theta. This is the theta.
BD.
Yeah, the opposite side means the opposite side of the sin theta, that is BD. So it becomes BD divided by hypotenuse is the same. What is the hypotenuse? Hypotenuse is fast.
AB.
AB, the same. Hypotenuse is AB. Okay, or we can write sin theta is equal to BD divided by, what is the value of AB from the figure AB? Q, the same, Q. So from this, we can calculate the value of BD. So sin theta is equal to BD by Q, which implies, so here sin theta is equal to BD by Q, which implies BD is equal to, any idea?
Q sin theta.
Very good, Q sin theta. So now we get the value for AD and that of BD. So here BD is Q sin theta. What is the value of AD? AD is Q cos theta. So now we can substitute the value of this AD and BD to where? To which equation? Into the equation for the resultant vector, that is R square is equal to P plus AD the whole square plus BD square. So write the next step. So here BD is equal to Q sin theta and AD is equal to Q cos theta. Not Q cos theta. Okay. Okay, now we can substitute this value into the expression for the resultant vector. Try the next step. Therefore, the magnitude of resultant vector becomes, write the equation for calculating the magnitude of resultant vector. Therefore, the magnitude of resultant vector becomes vector R is equal to, what is the equation? Not vector R, simply the R, the magnitude. So the magnitude is represented only in terms of the symbol letter R, not it is represented by vector. The magnitude of vector R becomes R is equal to, what is our equation? R is equal to P plus AD square plus BD square. R is equal to, sorry, R square, right? R square is equal to P plus AD the whole square plus BD square. P plus AD the whole square plus BD square. Okay. Now we can substitute the value of AD and BD into the equation. It becomes R square is equal to P plus AD. What is the value of AD?
Q cos theta.
Q cos theta. So it becomes Q cos theta the whole square plus value of BD. Value of BD is Q sin theta. But here we have BD square. Not the simply the BD. Instead of that, here we have BD square. So it becomes Q square sin square theta. Q square sin square theta. BD is Q sin theta, but here we have BD square. That is why we taken it as Q square sin square theta. Again, the first term is in the form of an identity. What identity that we can use here in order to solve this P plus Q cos theta the whole square?
A plus B whole square.
Very good, very good. So here we can use the identity. We know that A plus B the whole square is equal to. What is the equation for A plus B the whole square?
A square plus 2B plus
A square plus 2AB plus B square. So we can use the same equation here in order to solve the first term. The first term is P plus Q cos theta the whole square. So the equation becomes R square is equal to P plus Q cos theta the whole square. So it is P square plus 2PQ cos theta plus Q square cos square theta plus the last term. What is the last term present in that equation? P plus Q cos theta the whole square is solved. It is solved in the form of P square plus 2PQ cos theta plus cos square theta. Q square cos square theta. Q square cos square theta. Okay, so the first term is over. Then what is left here? Q square sin square theta plus Q square sin square theta. Okay, so the equation becomes R square is equal to P square plus 2PQ cos theta plus Q square cos square theta plus Q square sin square theta. Okay, or we can write R square is equal to P square plus 2PQ cos theta plus, which term is common here? Q square cos square theta plus Q square sin square theta. Which term is common?
Q square.
Q square is common. So we can take it outside. So it becomes Q square into, inside the bracket, we have cos square theta plus sin square theta. So R square is equal to P square plus 2PQ cos theta plus Q square into cos square theta plus sin square theta. Now again in trigonometry, what is this cos square theta plus sin square theta indicates?
1.
1. Okay. So in trigonometry, we studied that cos square theta plus sin square theta is equal to 1. So this term becomes equal to 1. Those who are not knowing this relation, take it as a side note. Cos square theta plus sin square theta is equal to 1. So the last term, cos square theta plus sin square theta is equal to 1. Then our equation becomes R square is equal to, what is left then? P square plus 2pq cos theta plus q square into 1. That is q square. Is it clear?
Yes, ma'am.
Okay. So the magnitude of R, the magnitude of the resultant vector becomes R square is equal to P square plus 2pq cos theta plus 2pq cos theta plus q square. We want to calculate the magnitude of R, not the resultant vector R, not the R square, which implies R is equal to the magnitude of resultant vector R is equal to square root of P square plus 2pq cos theta plus q square. So this is the final equation. That is the magnitude of the resultant vector R using the analytical method. So by analytical method, the resultant vector R is equal to root of P square plus 2pq cos theta plus q square. This equation is very, very important. We need this equation for doing the calculations and numericals and all. Okay. So today we are only deriving the equation for magnitude of resultant vector. Is it over? Okay, so the final expression is very, very important. Using the vector analytical method, the resultant vector R is equal to this equation, root of P square plus 2pq cos theta plus q square. And this equation is also known as law of cosine. This equation is known as law of cosine. Law of cosine. This equation is known as law of cosine. This is the magnitude of the resultant vector, and this equation is known as law of cosine in vector addition using analytical method. Law of cosine. Okay, that's all for today. I know this is a very large derivation and all. Try to study the final expression. Okay, that is R is equal to magnitude of the resultant vector R is equal to root of P square plus Q square plus 2PQ cos theta.